Number 10 gives you 3 tables. Each table below represents sets of ordered pairs from 3 different functions. So the families of functions, this guy is linear. This one, because the exponent is a 3, it's a cubic. And this one, because the exponent is x, it is exponential. So those are the 3 families. Okay, we know linear looks like a straight line. We don't know what cubic looks like. We haven't talked about it. Exponential, we know that it starts and then curves and takes off way quick. Okay, so the question is, as the x increases, so when x gets bigger, so the biggest x is 3 in all of them, the biggest x is 3. So what happens when x gets bigger? Which function will have the greatest value? So this 3 gives me an 8, this 3 gives me a 27, and this 3 gives me a 24. So far that is the biggest value. So now what happens as x gets bigger? Which one of these 3 is going to grow the fastest? It is definitely not the linear. The linear is just going up by 8 every time. Up 8, up 8, up 8, up 8. The cubic, if I plug in a 5, so if we put a 5 here, that is going to be 5 cubed, which is 5 times 5 times 5. And 5 times 5 times 5 is 125. But if I put a 5 into the exponential, it's going to be 2 to the 5th. That's going to be 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5. And 2 to the 5th, if we do that real quick, 2 to the 5th is 32. So it looks like the cubic one is getting bigger, but it's the exponential. The exponential may start off growing slow. 1 doubles to 2, doubles to 4, doubles to 8. But if we plug in bigger x's, the longer this x grows, the more steep this curve is going to get, and the faster the exponential is going to grow. So let's try like 7. If we try 7, okay, 7 cubed is going to be 7 times 7 times 7. On the calculator, 7 cubed takes me to 343. But if we do 2 to the 7, if we plug 7 in this exponential, it's going to be 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 6, 7. 2 to the 7th, still might not catch it. No. Now we're at 128. So when is it going to catch it? Let's try 9. What's 9 cubed? What's 9 times 9 times 9? 9 cubed. Ooh, that's 729. So 2 to the 9th. Let's see what that takes to. Ooh, we're getting closer. 2 to the 9th is 512. So maybe it catches it on 10. So let's try like 15. If I do 15, if I plug 15 in for the cubic, so 15 cubed, that's 15 times 15 times 15. That is 3,375. And if I do 15 into the exponential, 2 to the 15th, that's a lot of 2's, 2 to the 15th. Okay, there we go. Check out what it is at 2 to the 15th. It is 32,768. So, shortly after the 9th x, this exponential is going to take off and it's going to pass all the other functions. So this one is going to have the greatest value. It's going to grow the quickest. 11. This graph shows the savings accounts of 3 classmates. So Steve is this guy right here. Now Steve's savings never ever changes. Doesn't go up, doesn't go down. So Steve is not adding money to his account. He's not taking money from his account. His account is just staying at whatever this number is. If this number is $1,000, Steve's staying put at 1,000. Quinn is this one, and Quinn starts off with the same amount as Rachel. So Rachel's this one. So they both start off. If that's $1,000, maybe that's $100. Now the difference between Quinn and Rachel. Rachel is linear, so her slope is the same. Over 1 month, up $20. Over 1 month, up $20. Over one, every month she is depositing the same amount of money. Quinn, maybe she doesn't deposit much. Maybe she deposits a little bit, but then hers really starts to grow quick. She starts depositing a bunch of money. So we gotta figure out which one of these describes what's going on. A, Rachel adds equal amounts of money each week. Yeah, that is true. She adds the same amount each week. Quinn contributes once and earns no interest. She contributes once and earns no interest. That's not true. Okay, Rachel adds equal amounts. So it's got to be Rachel adds equal amounts. Rachel earns compound. That's not it. Rachel earns so I think it's got to be B. Quinn earns compounding interest. Compounding interest grows quick. So that's it. And Steve contributes once and earns no interest. That is true. And number 12, the table shows values of two functions over several values of x. Okay, this guy right here, that 2 means it's going to be a quadratic, and this guy is exponential. So exponentials, those are the ones that grow the very fastest over time. It might take them a few to get warmed up, but once they start building, and this is the rate of growth, since this is a 2, that means it's doubling every time. So at first it goes slow, 2 to 4 to 8 to 16, 32, but once it starts picking up speed, they take off way quick. So, look at the 7th x. The 7th x, the quadratic's at 64, and the exponential is already at 128. So what general fact about polynomial, that here are the polynomial functions. Polynomial functions are linear, quadratic, cubic, degree 4, quartic. All of these are polynomial. Exponential is when your x is in the exponent spot. So what's the difference about polynomial versus exponential? Polynomial are always larger than exponential. That's false. Exponential are always larger. Okay, that's kind of a trick question. That one's false too. Because look right here. Right there, the polynomial function, the quadratic, 9 is bigger than 4. So exponential functions are not always larger, because this one's bigger too. 4 is bigger than 2, and this one's bigger. 16 is bigger than 8. 25 is bigger. So it's bigger until like the 5th one. So the exponentials start slow, but once they get big, they take off huge. So it's not B. Polynomial functions increase faster than exponential. That's not true. Exponential functions increase the fastest. That's D. Number 13, recreation. The charge for renting a bicycle from a rental shop from 4 different amounts of time is shown at the right. Identify the type of function that models, and then B, write a graph. And write and graph a function. So here we go. Time. Let's go time right here. Time. and this is going to be money. So time, a half hour. So time is in hours. Half hour, 2 hours. So let's go right here. We'll call this 0.5. We'll call this guy 2 hours. And 1, 2, 3, 4. We'll call this guy 4 hours. And then maybe we'll call this guy 24 hours. Somewhere clear over here. Okay. So the money, $5. Let's put $5 right here. And then let's jump clear up here maybe and call that $25. And then let's call this $40. Let's call this $65. So you can rent a bike. So the first half hour they're going to charge you $5. So right here, we're going to circle that, we're going to circle that, and we're going to connect it. Anything from time 0 to a half hour is going to be $5. You actually, at time 0, you don't have to pay $5, so that's empty. This guy's got to be shaded in because at a half hour you got to pay $5. Now anything from a half hour to 2 hours, so if you want to rent it for 35 minutes, anything past 30 minutes, you got to pay $25. So $25 all the way to 2 hours, and everything in between. Doesn't matter if you rent it for 30 minutes and 10 seconds. Anything past 30 to 2 is $25. So 30 minutes right here is empty because I don't pay 25, I pay 5. But this is shaded. So this is going to be a step function. 2 to 4 hours, you got to pay $40. So $40, clear over to 4. There we go. And then anywhere after 4 to 24 hours, a whole day, 4 hours, it's going to be $65. So there we go. Okay, now let's write the function. Oh, we gotta write it. Okay, so this is gonna be a piecewise function. So if we've got f of x, there's 1, 2, 3, 4 pieces. So your bracket. Okay, f of x equals this one. They're all horizontal, so they're pretty easy. It's just y equals 5, y equals 25, y equals 40. These are the functions. Horizontal ones are the easiest. So it's y, that's the same thing as y. Y equals 5, y equals 25, y equals 40, and y equals 65. So those are the 4 pieces. Now, it only equals 5 if the time is between 0 and 30 minutes. If the time, so you can write it a couple ways. If the time is greater than 0 and less than 0.5. So we write it like this. You'll see it like this. Time is right in the middle. It's less than or equal to 0.5, but it's greater than 0. So the time's got to be bigger than 0. It's in between 0 and 0.5, but it's equal to 0.5. Okay, 25. It's only 25 if the time is less than or equal to 2, but it's bigger than 0.5. And it's 40 if the time is less than or equal to 4, greater than 2. And it will equal 65 if the time is less than or equal to 24, greater than 4. So that's how you write it. 14. Write a function for the following transformation. So this is f of x. Slide it down 3 times and left 1. So if you graph this, x minus 3, your a is 1, h is 3, and k is 2. So you're going to go right 3, 1, 2, 3, up 2, and there is your vertex, and it's quadratic, so it's going to be something like this. So you need to slide it down 3 times. So you got to take this vertex and go down 1, 2, 3, and left 1. So it's going to be right here. So my new A is still going to be 1. My H, that's the left right. So I went right to the 3 times. So if I slide it left 1, my new H is going to be 2. And my K, you need to go down 3 times from where it was, and it was up 2. So if you go up 2 and you go down 3, it's going to be a minus 1. So my new function is going to be y equals 1 x minus 2 squared minus 1. Okay, 15. A is 1, B is 3, or not B, H. K is 0. So if you graph it, you are going to go 3 to the right, dun, 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 not up or down. It parks right on the axis, and the slope is just 1, something like that. Pull up a chair. Okay, so now let's do this. Let's flip it over the x-axis. So that's going to flip right there. Slide it 4 times to the right. So 1, 2, 3, 4, and up 2 units. 1, 2. There we go. So it's going to look something like this. So my new A, if you reflect it, that's just a negative 1. My new H is how far to the right we are. So we used to be right 3, then we went 4 more, so my H is 7, and my K is how far up and down, and my K is up 2. So my new equation is y equals negative x minus 7 squared plus 2. Okay, 16. Okay, so from the first week of school, this is a review. I hired Hank to build the pig pens for me. I checked on his work every hour, and this is what I saw. How many panels? So this is a panel. That is 4 panels. 1, 2, 3, 4, 5, 6. This is 7 panels. Did we decide the panels go up by 3? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 panels. 13 panels. Okay, here we go. So this is hours. This is panel. So 4 hours takes him 4 panels. 5 hours, 7 panels. 6 hours, 10 panels. 7 hours, 13 panels. 8 hours, 16 panels. 9 hours, 13 panels. So because every time it's increasing the same amount, it is growing at a constant rate, this is linear, belongs to the linear family. And linear is y equals mx plus b. So all we need to do is find m and find b. M is your slope, it's how much it's growing. So these are going 3, and these are going up 1, up 1, up 1. So your m is 3 over 1, or it's just 3. Okay, now b is what you start with at 0. So you've either got to count back to 0, 3. Now let's go back 3, that give you 1, 2. If you go back 3, that give you minus 2. 1, if you go back 3, that's a minus 5. 0 should be a minus 8. So the b is a minus 8. So your function is the panels, the number of panels is equal to 3 times the hour minus 8, or it's y equals 3x minus 8. So let's test it, let's try it out. 8 has got to give you 16. So this is 8 hours. So plug in 8 for x, and 3 times 8. 3 times 8 is 24. And 24 subtract 8 is 16. So that's it. Number of panels equals 3 times number of hours, and then subtract 8. Okay, your domain. The domain is the x's. The domain is the hours. So the domain is the hours, and the range is the panels. So hours, the smallest hour maybe is 0, and you can go all the way to infinity, but we're not counting by seconds or minutes, so you cannot just go from 0 to infinity, because that includes everything. And we don't have something for 1 hour 25 minutes. We don't know how many pounds that is, so our domain's got to count by ones. So we got to go 0, 1, 2, 3, dot dot dot. We got to count by ones. What's up, Brinkley? Panels. Here, come in here. Panels. You got to count by threes. So 0 was a negative 8 panels, but negative 8 panels really is not a thing. So panels, maybe the smallest, you could have 1 panel, then you could have 4 panels, then you could have 7 panels, 10 panels, dot dot dot, all the way to infinity. Okay, last one. A boy doing chores for a neighbor calculates that given the rate he paints fence posts and the amount of money he makes per hour, he earns 20 cents per fence post. He wants to create a function that tells him how much money in dollars he earns per fence post. So the money he earns is equal to 20 cents per post. Okay, 20 cents. That's got to be 0.20. So the money he makes in dollars equals, because if you do 20p, that's 20 bucks per post, we'll say. So it's really y equals 20x. But since you want it to count in dollars, that 20 means $20, but he does not earn $20, he earns 20 cents. So it's got to be 0.20. There you go. So your table, the x is post and the y is money. So if he does 1 post, he gets 20 cents. 2 posts, 40 cents. 3 posts, 60 cents. 4 posts, 80 cents. Okay, so what are a good domain? Domain is the x, so this is the domain. So domain is the post number, and the range is the y, so the range is your money. So what's a good domain? All integers as the domain. Okay, that's not it, because the smallest post is 1. Integers are all the positives and all the negatives. So we really don't have any negative posts, and we don't have any negative money, so everything's got to be positive. All real numbers, that's not it. Real numbers are all the negatives, all the positives, all the decimals, all the fractions, everything. All positives, okay, this sounds better. All positives as the domain, and all positive multiples of 20 as the range. Okay, I like that. D, all positive integers as the domain, and all positive multiples of 1/5 as the range. Okay, these two are really good. C and D are really good. It's going to be D, only because they want dollars. And 20, 1/5, that is 0.20. That's 20 cents right there. 20 cents is 1/5 of a dollar. Counting by 20s, we're counting by 20s, but if it's in dollars, that'd be $20, $40, $60, so it's got to be cents. So 1/5, counting by 0.20, because 20 cents is 1/5 of a dollar.